4.3, example 4. In this example, we're going to look at a situation where they don't give us theta, but they tell us what one of the trig functions is equal to and something about a second trig function. Then what we're going to do is we're going to determine the values of the 5 remaining trig functions. So in example 4, we have tangent of theta is equal to 12 over 5. We also know that sine is less than 0. So this actually gives us a lot of information. I know it doesn't look like it, but we have a lot. We have that because tangent of theta is equal to 12 over 5, we know that tangent is positive, and we know that y is equal to 12 and that x is equal to 5 since tangent is y over x. So this gives us the coordinate 5, 12. The only thing it doesn't tell us, though, is which quadrant it's in, so we actually don't know if these x and y's are negative or positive. However, we do know that sine is less than 0. So because sine of theta is less than 0, we know we're in quadrants 3 or quadrants 4. Because tangent is positive, we know that we're in quadrant 1 or quadrant 3. So right here you can see that we have quadrant 3 twice, so we know for sure that we're not in quadrant 1 and we're not in quadrant 4. Another way you can do this is by drawing a picture to represent this. So I'm going to draw a quick little grid and then put in my acronym of all students take calculus. And if I look at where tangent is positive, I'm going to put a check, and where tangent is negative, I'm going to put an X. So tangent is positive in quadrant 1 and quadrant 3. It's not positive in quadrant 2 and 4. I'm going to do the same thing for sine. So sine is less than 0 in quadrant 3 and 4, and it's not less than 0 in these two quadrants. So you can see how quadrant 3 has 2 check marks where all the other ones do not. That's how we know where to put our triangle. So this actually tells us that the point 5, 12 is actually negative 5, negative 12. And now this is very similar to a previous example that we're actually just going to graph it. So I have my grid, and I plot the point negative 5, negative 12. And so now I have the dimensions of the triangle all drawn out. All I need is r, because again, I'm trying to find those 6 trig functions. So I go negative 5 squared plus negative 12 squared is equal to r squared. So I get r is 13. Again, here is the angle that I'm going to be working with. So now all I have to do is find all 6 trig functions. So we know that sine is going to be y over r. So sine is negative 12 over 13. So then cosine is going to be negative 5 over 13. And tangent is going to be 12 over 5. So then cotangent is 5 over 12. Secant is negative 13 over 5. And cosecant is negative 13 over 12. So now on your own, I want you to try to determine all 6 trig values for A and B. So for part A, we're given that secant is equal to radical 3 and tangent of theta is less than 0. The way I like to start this is actually just by writing all the trig values or trig functions out that I want. And now at this point, I'm going to go ahead and fill in what I know. So I know secant is radical 3, which means cosine is 1 over radical 3, which is going to be radical 3 over 3 when you rationalize it. Okay, so now let's use the information we know to pick the quadrant. So to do this, I like to just draw a little axis real quick. Just put that in there. And then put my little acronym, all students take calculus. So let's start with secant. If secant is positive, that means cosine is positive. And so it's positive here, and not in quadrant 2 and 3. And then tangent, I'm going to go ahead and do in purple. If tangent's negative, so it's not here. It's negative in quadrant 2. It's not negative in quadrant 3, and it's negative in quadrant 4. And so now we can actually determine which quadrant we're in. So we're in quadrant 4 because it has 2 check marks, or mathematically because it satisfies both. And so now we can go ahead and draw our triangle. So the problem is I don't know where to put the triangle. So I'm going to go back to what I know. I know that cosine of theta is equal to radical 3 over 3. I also know that cosine is x over r. So from this information, I know that x is going to be radical 3 and r is going to be 3. So then I go ahead and just draw a triangle in here. And I know that this is radical 3 and I know this is 3. So then I got to use the Pythagorean theorem to find the last side. So I get the last side is the square root of 6. And now I can go ahead and just plug in everything to get the remaining values. So I have sine then is negative radical 6 over 3. And tangent is going to be negative radical 6 divided by radical 3, which gives me negative radical 2. And now I have to take the reciprocals to find cosecant and cotangent. So I get negative 3 divided by radical 6, and then I rationalize it. So I get negative 3 radical 6 divided by 6, which is negative radical 6 over 2. Cotangent is going to be negative 1 divided by radical 2. So you go ahead and rationalize it, and you get negative root 2 over 2. All right, let's do part B. So in part B, we have that sine is 5 over 7, and cotangent is greater than 0. So again, I like to start just by writing everything I know. Well, if sine is positive, we know it's going to be in quadrant 1 or quadrant 2. And if cotangent is positive, let's remember what that means. That means that 1 over tangent is positive. And if that's positive, we're going to be in quadrant 1 or quadrant 3. So right away, I know that I'm going to be in quadrant 1, but I'm going to show you how to go ahead and use the sine chart to do that. We also know that sine is 5 over 7. So if sine of theta is equal to 5 over 7, then sine of theta is also equal to y over r. So then y is equal to 5, and r is equal to 7. So using the sine chart, you can go ahead and just draw a quick little one. And you go, all students take calculus. Well, sine is positive in these two quadrants. It's not positive in these quadrants. And tangent's positive in these two quadrants and not in these two quadrants. So you can see how we're in the first quadrant. Okay, now we're going to go ahead and draw our triangle. So I'm just going to put my point right here. I don't know exactly what it is, but I know this is going to be 5, and this is 7. And again, that's based on the sign that's given in the problem. So now I have to, again, use the Pythagorean theorem. 5 squared plus, this time I'm solving for x. So I get my x value is 2 radical 6. And now that's all I have to do is plug everything in. So let's remember what was given. We were given that sine is equal to 5 over 7. So right away I get cosecant for free, which is 7 over 5. And then cosine is going to be x over r. So cosine is 2 radical 6 over 7, which would make secant 7 divided by 2 radical 6. And then we have to rationalize it. And then tangent is going to be y over x. So you get 5 divided by 2 root 6. Again, you have to rationalize it. And then for cotangent, you take the reciprocal. But I recommend to take the reciprocal of this and not of that. They're both the same number, but one you're going to have to re-rationalize and one you won't. So this will be 2 radical 6 divided by